In order to talk about the physical and chemical properties and changes, you need to know the three basic forms of matter. Solid, which has a definite volume and definite shape. Liquid, which has a definite volume but no definite shape. And a gas, which has no definite volume and no definite shape. It'll fill its container. One special type of gas is called a vapor. A vapor is a gaseous form of a substance, but is normally found as a liquid or solid at room temperature. For example, if I were to squirt a little bit of water on the table and I came back the next day, the water would be gone. That is because it is evaporated into a gaseous form. But because that water is now a gas, but is normally found as a liquid or solid at room temperature, we consider it a vapor, not a gas. The first property we're going to talk about is physical properties. Physical properties describe the physical state of a system. You do not have to change the substance in order to observe its physical property. There are two major categories of physical properties, intensive and extensive. Intensive is independent of the amount of substance. Extensive is dependent on the amount of substance. Let's go through some examples of intensive physical properties first. Color. Notice it is independent on the amount of substance you have to observe its color. Whether it's long or short, or tall, or big or small, it's still going to have the same color. Notice we also don't have to change the substance to see its color. Melting point, boiling point, density, and hardness. All five of those you can observe without changing the substance, and none of them will change whether you have a small amount of the substance or a large amount of the substance. Let's look at some examples of extensive physical properties. Length, mass, volume, energy, and electric charge. Notice you don't have to change the substance to observe these five qualities, yet the amount of substance definitely will affect their measurements. The other type of property is a chemical property. Chemical properties only become evident during a chemical reaction or a chemical change. Some examples are corrosive, toxic, flammable, strong oxidizer, meaning that it's able to steal electrons away from another substance, photoreceptive, meaning it will chemically change when activated by light, explosive, and inert. Inert means it's not chemically reactive. Even though it says it's not chemically reactive, it still determines its chemical behavior, so we consider it a chemical property. Chemical equations are a way to write out chemical reactions or chemical changes. For example, you might notice that when you take iron and react it with oxygen, it creates a whole new substance called rust. Since it changed its substances, that's why we call it a chemical change. Now a chemist might write this out as Fe plus O2 yields Fe2O3. In order to talk about physical and chemical changes, we need to talk about the law of conservation of mass. The law of conservation of mass tells us that the mass before a chemical or physical change has to be equal to the mass after the chemical or physical change. For example, if I have a block that weighs 10 grams and I cut it in two pieces, we have no idea how much each one of these blocks weighs until we know one of them. If this one weighs 6 grams and we know that those two on the right must equal the one on the left, then the smaller block must equal 4 grams. Another example, if a person leaves 10.4 grams of iron out in the front lawn for a long enough time that it has completely turned into 15.7 grams of rust, what mass of oxygen was used in the reaction? Well, here's what we know. We know we started out with 10.4 grams of iron. It reacted with an unknown amount of oxygen and formed 15.7 grams of rust. Well, the amount of rust has to equal the amount of iron and oxygen used due to the law of conservation of mass. So in order to solve this problem, we take the total weight, 15.7, we subtract off the amount of iron used, and we will find our 5.3 grams of oxygen.